Well, hello everybody. We are hoping that you did extremely well on your Chapter 4 test. We will get those graded and back to you next class. Hopefully they'll be in the computer even before then. What we'd like to do with you today is I'd like to cover Section 5-1 with you. Section 5-1 we've been doing within Chapter 4, so we basically didn't want to try to spend a class day on it. We can save that day on a day you're struggling a little bit and give you a little more time there. Some things that I need to make sure that you remember. We've been using SOHCAHTOA. Remember, guys, that stands for, if you're going to use the sine function, it's the ratio of the opposite side over the hypotenuse side. If you're going to use the cosine ratio, it's the adjacent side divided by the hypotenuse. And the tangent is defined as the opposite over the adjacent. We've been working with those, so we don't think you're going to have any problems with those. I also need to make sure you remember degrees, minutes, and seconds. We didn't do any seconds in Chapter 4. But remember, in 1 degree, there are 60 minutes. And based on our normal time, in 1 minute, there are 60 seconds. So that also means that in 1 degree, there are 60 times 60, or 3,600 seconds. So here in one of our problems coming up, you're going to see something like 23 degrees, 42 minutes. Well, the way I'm going to handle that to convert it to degrees, I'm going to call this 23 plus 42 60ths. That's how we're going to handle that here in just a little bit. If you will, scroll on over to your number 1. I'm going to click right through these because, like I said, I believe it's review. So here goes. In right triangle ABC, the leg opposite A has a length of 20. Let me pause here for just a second. If you will, draw some right triangle. And then, guys, remember, it doesn't matter how you label it. Traditionally, with the right angle, we put C. The other 2 angles could be whatever you want to call them, A or B or B or A. Notice that I used capital letters. Capital letters represent the angles. Small letters represent the sides. So if this is angle A, over here is side A. If this is angle B, over here is side B. And of course, if that's angle C, this is side C. Now let me go in and fill out what I got. The leg opposite angle A. So we're going to be talking about angle A. Angle A right now becomes my reference angle. That's where we're going to talk from. The leg opposite A has a length of 20. So I'm going to shoot across from A, and that's 20. The leg adjacent to A has a length of 21. We have to remember what adjacent is. This guy over here is the hypotenuse, so he can't be the adjacent, so that must be my adjacent. I also need the hypotenuse, so we're going to use the good old Pythagorean theorem. 20 squared plus 21 squared equals C squared. Add those up, run them through your calculator. You'll find that side C is 29. Now that we have that, we're off to the races. I would like to go get the sine of angle A. So from angle A, I'm going to go do the opposite over the hypotenuse. So from side A, angle A, shoot across, there's the opposite. So I've got 20 over 29. And then stop. You're all done. That would make cosine of angle A the adjacent over the hypotenuse. I'm going to move that right out here. And looking at that, it looks like that's going to be 21/29. And then stop. Don't type that in your calculator. Don't mess with it. And then let me move C right down here. For the tangent of A, tangent's going to be the opposite over the adjacent. So it looks like that's going to be 20 21st. Now in Part D, though, it says, find the measure of angle A. It doesn't matter which trig operation, A, B, or C, you pick on. I'm going to pick on A right now. I know that the sine of angle A is 20/29. Remember, to find an angle, we're going to have to use the inverse of whatever trig operation we're using. So I'm going to take the inverse sine of each side. So it looks like this for a minute. Now here's what we got to do. Make sure your calculator is in degree mode, because everything that we're going to do today, we want degrees. So I'm going to get back out of there. I'm going to type in my calculator now, second sine, and I'm working with the sine, so I'm going to go 20 divided by 29. Once your calculator sees that inverse sine or cosine or tangent, it knows to go get an angle measure. So I now know that the measure of angle A is about 43.6 degrees. If you would have picked the cosine operation, you would have went second cosine of 21/29. You would also have gotten 43.6. And if you would have picked the tangent operation of 20/21, you would also got 43.6. Moral of that story, it doesn't matter which trig operation you pick. Pick the one that you want to work with. Here goes my number 2. It says in triangle DEF, angle D is a right angle. So let's come over, sketch some right triangle, but make sure angle D is your right angle. And remember, it doesn't matter where we put those other two letters, E and F. Then it says if DF equal 40, so I'm going to put a 40 right there. EF is going to be 41. And then I need to use Pythagorean theorem to get side F, or side DF. So in this case, I know my hypotenuse, so I'm going to go 41 squared minus 40 squared equal F squared. I'm going to get 81 equal F squared. So I'm going to get F to be 9. Now I've got everything I need. It says the sine of E, so make sure you're starting from angle E. That's the key. So that's now going to be 40/41. Leave it as a fraction. Cosine of E is going to be 9/41. And the tangent of E looks like the opposite over the adjacent, so 49. And then to find the measure of angle E, pick whichever one of these trig operations you want. I'm going to go second sine, 40 divided by 41. Tells me that the angle is approximately 77.3 degrees. So there's just a little SOHCAHTOA review. I wanted to add in how to find the measure of an angle. We talk about the graphs of those next time. Jump on over to number 3 if you would. This one says, suppose the distance along the slope from the top of a bank of a river to the edge of the water is 23.6 meters. And a surveyor finds that the land slopes downward at an angle of 26 degrees from the horizontal, also called the angle of depression. Find D, the horizontal distance from the top of the bank to the river's edge. So here's what we got going. We have our land, and then we have a slope that's coming down to the water. We now know that this is 23.6 meters. And here's what they're saying for this angle of elevation. If I extend that out, I know that this angle is 26 degrees. I'm going to draw my right angle right here, and they're wondering how far that distance is right there. So just to kind of give you a better picture, I've got 23.6 right here as my hypotenuse. I've got a 26 degree angle, and we are looking for that right there. You have to decide which trig operation to use this time. So based on your angle, I'm working with the hypotenuse. I'm working with the adjacent. So think back to your SOHCAHTOA and decide what we're using. So it looks like we're using the cosine. So this is going to be set up as cosine of 26 degrees equal d over 23.6. This problem is pretty nice. Check out what happens when I cross multiply. When I cross multiply, d is all by itself. As a suggestion, whenever you're taking a trig operation of an angle times some constant, write the constant first. So write this as 23.6 times cosine of 26. Now when you come into your calculator, I'm going to go 23.6 cosine of 26, enter, and I get about 21.2 meters. You don't have to write it that way, guys, but I've seen this happen before. We get carried away and we go cosine of 26. We forget to close that parenthesis, so this happens. So we go cosine of 26 times 23.6, and we get some answer that we know couldn't happen. So like I said, you could type that in, but you would have to remember to close that off and type it in that way. So just a suggestion there, put the constant up front and you should be good to go. Jump over to your number 4. A surveying instrument is 4.5 feet above the ground. A surveyor marks off a point 50 feet from the base of the cliff and measures an angle of elevation to its top to be about 61.39 degrees. Find the height of the cliff. Well, here's what we got going. We have some tool that's 4.5 feet off the ground, and it's eyeing the base of a cliff 50 feet away. And here's going to be the height of my cliff over here. Notice that this is not drawn to scale. The only other part I have is this angle is 61 degrees 39 minutes. And we're going to try to find x, the height of the cliff, or c for the height of the cliff. I didn't want to use c and confuse somebody with hypotenuse. So once again, decide what trig operation we're using. There's the opposite side. There's the adjacent side. So it looks like we're going to use the tangent function. Now when I do this, I'm going to have tangent of 61 degrees 39 minutes. But here's how we're going to write that. We're going to write it as 61 plus 39 sixtieths. That's how we're going to write that. Equal x over 50. This one's another nice one because, once again, guys, when I cross multiply, my variable is all by itself. So I'm going to have x equal 50 times the tangent of 61 plus 39 sixtieths. And then let's go run that through our calculator. So it's going to look like this. 50 tangent, 61 plus 39 sixtieths. So it's going to look just like that. When I do that, I get x to be about 97.2 feet. But notice that's not our answer, is it? I need to add in this 4.5 feet for the height of my instrument. So let's come in and also add in another 4.5 feet. So it looks like this thing's going to be about 97.7. Oh wait, yeah, let's add in 4.5. This should have been, I wrote this backwards. Let me backtrack real fast. That's what I get for looking ahead. When I run that through my calculator, hopefully you're with me, this should have came out to be 92.7. Now when I add in my 4.5 feet, I should get about 97.2 feet. I was looking ahead. I added that in my head and I shouldn't have. So there's what I got when I ran that through. Then I had to add in that 4.5. Then it looks like we got 2 to go. This might be a new concept for you on this one, guys. It says a ship's on a bearing of 55 degrees. You're going to see the word bearing a couple of times in this chapter. Here's our definition of bearing. A bearing is the number of degrees clockwise from the north. So here's what it means for a ship to be on a bearing of 55 degrees. We have our axis, where I got north, east, south, and west. And we always go clockwise. So we're rotating this direction all the time, whenever we're working with a bearing. So a ship being on a bearing of 55 degrees means this. Instead of going due north, it's going to go 55 degrees that way. So let me clean that up just a little bit for you. Here's going to be my ending picture. I got my ship traveling here, and this is 55 degrees. Here's going to be my triangle. This is a little bit different than our reference triangle. Remember, in our reference triangles, we always draw it back to the x-axis. So here's the triangle I got going right now. I got 55 degrees. I know that's heading north. Now I'm heading east. Now let's see what else it says we need. It says a ship's on a bearing of 55 degrees. How far is the ship if it's sailed 350 kilometers north of its original position? Well, what that means is he's gone 350 kilometers. And it wants to know how far has the ship sailed. I would like to find this distance right there. So there's my main setup. Once again, we have to decide what trig operation you're working with. From this angle, it looks like I'm working with the hypotenuse, and it looks like I'm working with the adjacent. Looks like the cosine function, so I'm going to have cosine of 55 equal the adjacent over x. Notice this time, guys, when I cross multiply, x will not be by itself. I'm going to have x times the cosine of 55 equal 350. To get x by itself, I need to take 350 divided by cosine of 55. So let me take 350 divided by cosine of 55. Tells me that my ship has went approximately 610.2 kilometers. So there's what we got so far. On part B it said, how far east of its original position is it? Well, now it would like for us to find that distance. So now we got a couple of things going. We now know this distance is 610.2 kilometers. So one way, I could use the Pythagorean theorem to go get the answer. Another way, and I'm going to go this route just to be more exact, I'm going to try not to use that number because we rounded it. I might look at my 55-degree angle and say, well, I'm looking for the side opposite of it. I've got the adjacent, so there would be the tangent. So I'm going to say the tangent of 55 equal how far east over 350. This one's going to be pretty nice because when I cross multiply, my variable's by itself. So I'm going to take 350 times the tangent of 55, and I'm going to get about 499.9 kilometers. So I went 350 times tangent of 55. So right there. Like I said, guys, you could also use the Pythagorean theorem. Now part C says this: if the ship's average speed is 15 kilometers an hour, how long has it been sailing? Well, you need to remember that distance is rate times time. You jump on the interstate driving 70 miles an hour for 5 hours, you went 70 times 5, 350 miles. Same concept here. I know the ships went 610.2 kilometers equal its rate of 15, and we're looking for how much time. So let me solve this. So I'm going to get about 610.2 divided by 15. So I know this ship's been going for about 40.7 hours. We got one more bearing problem. We're going to switch it up just a little bit, but that's going to be the steps of them. So here goes our last one. It says a ship is on a bearing of 42 degrees from the south. Well, here's what we got to do to get this. Once again, there's north, east, south, and west. So it says the ship's on a bearing of 42 degrees from the south. So instead of heading due south, straight due south, I need to go clockwise 42 degrees. So I need to go that way 42 degrees. So here's what I've got. There's my ship, and I know right here is 42 degrees. So I'm going to draw my triangle so that it includes that 42. So for a nicer triangle for you, here's what we got. I know that this is 42 degrees. That's all I got so far. Now let's pick on part A. How far has the ship sailed if it's 400 miles south? So I know that this is 400. There's my right angle. And we're looking for this distance right there. So from this angle, looks like I'm working with the hypotenuse and the adjacent. So that's the cosine. So I've got cosine of 42 equal 400 over x. X will not be by itself when I cross multiply. I'm going to have x times cosine of 42 equal 400. So x is going to be 400 divided by cosine of 42. 400 divided by cosine of 42. So it looks like will have traveled approximately 538.3 miles. So I now know this distance is about 538.3 miles. On part B it says, how far west of its original position is it? Well, so I would like to now find that one. So you could, if you wanted, Pythagorean theorem. But I'm going to come and try to use the exact values. I'm going to try to use that value and that value, which looks like the opposite and the adjacent. So I'm going to come over here and say tangent of 42 equal the opposite over the adjacent. Notice that when you cross multiply, W is going to be by itself. So W is going to be 400 times the tangent of 42. So it looks like west distance-wise, we're going to be about 360.2 miles. Last but not least, if the ship's average speed was 24 miles per hour, how long has it been sailing? Well, I'm going to take my distance equals rate times time. The distance we traveled, 538.3, equal my rate of 24 times t. Let's take our 538.3 and divide it by 24. Going to be traveling approximately 22.4 hours. So guys, there is section 5-1. Hopefully you followed the video okay. What we did is we threw away the assignment part of it. So it looks like you devote 27, 30 minutes here, and you got section 5-1 done. Good luck.